Sometimes you make an electronic circuit, and with a power supply, of course, could be of any voltage. And for instance, you are charging a battery, nickel cadmium battery or so, and you want to know if whether there is really flowing a current in the circuit. And when you only see the voltage, for instance, parallel to a nickel cadmium battery or so, you don't have an indication that there is really current flowing, so the battery is charged. Could also be another situation, say you have a radio or whatever other device, and you want surely to know whether there is a current flowing into that radio or whatever device, etc. Well, I made this demo circuit for that purpose. It is, say, a kind of simplified circuit, but I want to show the principles. This is perhaps a video for the beginners, or anyway, doesn't matter much. Here you see my power supply, DC volts, 5 volts at the moment. It sends in current to this part of the circuit. There is one 10 ohm resistor here and one 10 ohm resistor here, and this is in fact the circuit. I've made use by purpose a silicon diode here for all cases where you want to use this, for instance, as a very elementary battery charger, where you can see that the batteries are really charged because there is an indication of current. In that case, this is the battery. Here is the voltage source, here is the diode that prevents that the current can flow back, and here is what I want to talk about, the LED, light emitting diode. I forgot to tell that light emitting diodes, according to their color, have a specific voltage where they start to burn or start to light up. And in case of a red LED, I think it's approximately around 2 volts. When you want to use here a white LED, it is around 4 volts anyway. So what's happening in this circuit is this. Here is the voltage supply, and for this demo purpose I've used two 10 ohm resistors. And when we apply Ohm's law, we can see that when we have, for instance, here 12 volts and two identical resistors, each voltage drop parallel to that resistor is half of the supply voltage when the resistors are identical. I've used 10 ohms because this is a demo circuit, and that means that when I had here 12 volts parallel to this 10 ohm resistor, there was 6 volts. By the way, when not the LED was connected, the LED is a diode, it has a certain fixed voltage drop. I will tell more about it later. So without that LED, when there was here 12 volt here, we had here 6 volt and here 6 volts. That's of course in this demo video not the case anyway. Some things to tell. Here the idea of the video, make the current flowing into something that could be everything, radio, battery, etc, with the help, visible with the help of one light emitting diode and one resistor. When fierce current starts to flow here, you must use here a power resistor, and that value is very easy to calculate. This is the calculation. The wattage of that resistor here, this one here, that serves the LED, depends on the current that's flowing and the voltage drop. Say we have... My camera stopped suddenly, so I have to glue two videos together, but anyway, I was talking about the dissipation, the wattage of the resistor that this resistor has to handle, and that depends on the current that's flowing and on the voltage drop. So it's very logical. Say when 100 milliampere flows in the circuit and the voltage drop is 2 volts, that resistor must be able to handle 200 milliwatts. Anyway, the load can be everything like I told. And here the big picture. This can be any silicon diode that can handle the voltage and the current. And I was talking about Ohm's law. I've made by purpose this unit here in a very simple way, so that I could tell more about the function of the circuit and how Ohm's law works in this circuit, etc., etc. So in general, when we have here two 10 ohm resistors, the voltage drop parallel to this resistor and that resistor is, say, half of the supply voltage. But like I told, that's not going very exactly, because in this case we have a diode here, and that diode is the light emitting diode. Perhaps somewhat confusing, but anyway, let me try. So what is the voltage that is now parallel to the whole circuit? That voltage is 5.1 volts. What is the voltage drop parallel to the 10 ohm resistor that makes that the light emitting diode lights up? That is 1.9 volts. What is the voltage drop parallel to the load? The load is here, that could be everything. It's now a resistor, could also be a nickel cadmium battery or so. That is 2.5 volts. And want to give a demo. When we say lift up the voltage here, the power supply voltage is now 5 volts. Let me show what happens. I will put out the lights and also the other light. So this is a red LED. Like I told, every color of the LED, that's what I wanted to tell, has a specific barrier voltage. So a green LED has an other barrier voltage compared to a yellow LED or a white LED or a green LED. That means that the voltage drop caused, say, paralleled over the 10 ohm resistor in this demo circuit, varies with the input voltage. That also means that, for instance, with a green LED you get somewhat other results anyway. Now drive up the voltage somewhat, and you can see here the indications on the meter. Now it's 2 volts parallel to the 10 ohm resistor that drives the LED. Here there is 4.2 volts parallel to the load. Anyway, the idea of this video was to give a very simple solution to make current in a certain circuit visible. I hope I succeeded a little bit. Perhaps it was somewhat sloppy because my camera stopped suddenly. Anyway, this is the basis of the schematic here. And when the LED here is too fierce or burns out due to a too high voltage drop, you can add here an extra resistor here. So this is 10 ohm. Here we have, say, 10 volts. It's far too high, the voltage drop far too high. But when you say, I have to disconnect this. When you say drive the LED with a series resistor here, the voltage drop, effective voltage drop here, is much lower. That means that with the help of this resistor, you can align the LED to the exact voltage that it needs. For a red LED around 2 volts, for a white LED around 4 volts. So this is crucial. Start for instance with a 1K resistor here. And for, say, low voltages in the order of 3 to 4 or 5 volts, such a resistor could not be necessary. Thanks for watching. In fact, it's very, very simple. And say, when you look at this circuit, you will surely understand, when you know Ohm's law, how such a circuit works.